All right, CNT125, Chapter 9. We're on the section on WAN technologies. We're picking up from DSL and cable. We're moving on to fiber now. A lot of ISPs are offering WAN connections that are fiber-based. And you might see a couple different variations of terminologies here. Fiber to the neighborhood, fiber to the curb, or fiber to the building, or fiber to the house or the home. These all really just define how far that connection goes out. So if fiber to a neighborhood, it's describing just that. It's getting connection out to a neighborhood. Then you might be using some other copper connection to connect to the house. Fiber to the curb, again, this might service a smaller neighborhood, maybe a cul-de-sac kind of thing, and it's getting fiber to there, to a box maybe in that neighborhood, or in that section of the neighborhood or that street, and then copper connections into the house. And then fiber to the building or fiber to the house is literally going to, in many cases, the side of the house with fiber, and then copper inside. We transitioned to Fios at our house a number of years ago, and it literally is fiber to the home. There's fiber coming from the pole to the side of my house and into the box that I have in my basement, and then from there out in my house, it's copper. It's copper in my house, but it's fiber to the side of my house. So this is actually a picture from our previous edition of the book showing you roughly what's going on. If I have in a fiber to like a home scenario or neighborhood, I would have fiber out to a box in the neighborhood and then copper cabling or coax cabling going to each of the houses. This would be kind of like the fiber to the neighborhood thing. Fiber to the house, I threw this in here to get you thinking. The provider is going to be doing multiplexing out to a box in the neighborhood to multiplex all those signals together and then break them out to go to all the houses individually. That's usually what's going on behind the scene. So thinking back to, I think it was Chapter 5, they talked about different types of multiplexing. This book mentions your wavelength division multiplexing. That's the kind of stuff going on behind the scenes to bring all those signals from a neighborhood into the provider. Here's breaking out a fiber to the home a little bit more, showing coming to the house, going into the house, and the kinds of things that are combined together in the house to go into the fiber network. One of the next options, leased line. Leased line. This would be a business type connection. You're getting dedicated bandwidth, your service level agreement that we talked about, and typically symmetric bandwidth. If you're getting, gig down, you're also getting a gig up as far as your bandwidth. You're going to have monthly costs for the lease line, and these are going to depend on a couple factors: the amount of bandwidth and the distance. So you might be spending, $500,000, $1,500 a month based on the bandwidth or distance for that link, for that connection too. I threw in here some pictures reminding you. I picked on Comcast Business, I picked on Verizon Business, but as I look in here, I start seeing dedicated internet. I start seeing here dedicated services. That's where you start seeing that. And you're not going to find a price on there because it has to do with, I'm going to back up here again, bandwidth and distance, bandwidth and distance. So these really do factor into, is it available for one? What kind of bandwidth you need? What kind of distance are you talking? Are you talking connecting to Harrisburg, New York? Are you talking connecting Harrisburg to Lancaster? Or even further, Harrisburg to Philly kind of thing? The longer the distance, the more the bandwidth, the more it's going to cost per month to have that leased line. But for some companies, having that direct leased line between sites is what's necessary for their businesses. The book also mentions MPLS, multi-protocol label switching. Again, familiarity here. If a company is using this, as you go through here, at least you'll understand what they're talking about, what is going on. This one is introduced in the late 90s, 99. It can handle a number of different payloads, and it actually works at, they like to call like layer 2.5. You'll see that here in a little bit. This is often used by ISPs to move traffic from one customer to another site, but some customers can have an MPLS connection from site to site as well. Again, they mention that because ISPs might actually be doing this and you don't even realize it, but you can actually pay for an MPLS connection from site to site. And what happens here is the routers The traffic moving through gets in, I'm jumping ahead of myself here, it adds in a little shim, and it's between the layer 2 and layer 3. And the routers read that. It does not dig any further. It reads that to just move the traffic through quickly. That way the routers don't have to continually maintain all these routing tables and everything else. It just reads a little label saying, oh, you're going that way? Go, go, go. And it does not have to continue to consult tables and so forth. So that's what it's actually going to do. Big benefits, it's highly scalable for businesses. Customers can prioritize their traffic. Maybe voice and video is going to get first. Data will get mingled in between them. And you can label traffic because of the label that offers more reliability, predictability, security on those connections. So here shows, a bunch of different sites, MPLS network, connecting those sites together. And your ISP is providing that service. Here, quality of service and efficiency, as we said. Quality of service, I can literally prioritize certain types of traffic moving across. Efficiency, the router does not need to dig into the layer 3 header. It's literally just looking at layer 2 and that shim and on it moves. So it moves traffic through a lot quicker. And that's why I showed that tag early on, this shim they call it, MPLS shim. That's why they call it a layer 2.5, because it is between layer 2 and 3. And then your MPLS network here, the customer edge router basically puts that in. It gets tagged, boom, and it follows that path, this kind of like predetermined path through, and the routers don't have to calculate these routes all the time. That's your MPLS network. In here, they mention about cloud connectivity options. If you're going to connect to cloud services, you might run into a colo or colocation service that your cloud service provider is going to provide to you. You lease a dedicated line from your ISP to one of the cloud provider's POPs, the colocation facility, to have a direct connection to your cloud resources, especially if you have resources on there like websites or anything like that you need access to. Maybe even it's like phone servers or things like that you need access to. So your cloud provider might offer you a lease line to their services that they're hosting for you. So this might be part of your WAN connection that you're doing from site to site. Book also mentions software-defined WAN. So here, I think I show an example right here. Your software-defined WAN connections are managed, and I think I show here the controller actually manages this connection, and it might be a variety of resources that are used to go from site to site. So this controller is now taking the place of all that routing table, that sort of thing, and saying, no, this is the way you go. You're going to use this and this and get there. That's your software-defined WAN. Active load balancing, it can fail over to other connections that you have. With this, you've reduced costs too, because I don't have to have some of these bigger technologies we mentioned before. There's a lot of places moving to this because they can use a variety of technologies at different sites, and this kind of oversees those. Wireless LANs. With wireless LANs, your 802.11 signal can travel basically a quarter mile. So that would handle, connections in and around a building or something like that. If I need a longer distance, now I need a wireless WAN. And these are designed for high throughput, long distance connections. So we have cellular and we have satellite. Those are the two main ones. Cellular, first introduced in the 70s. Massive changes in that since the 70s. It was just designed for voice before. Now we can data and voice across our cellular system, which many of us use frequently and kind of rely on as well. The coverage area is divided into cells, hence the name cellular network. Each cell is served by an antenna and a base station, cell site, and cell providers will typically lease the space on a tower. So the tower might be owned by A company, and the provider B company rents space on there to put their antennas, their antenna arrays, if you will. So the tower itself might be owned by company A, and these up here are owned by company B, and there might be other antennas owned by company C up there to provide service in an area. The infrastructure itself at the base station controller assigns multiple mobile clients frequencies and manages them. Cells are depicted by hexagons. As I look in I think there's a picture here, because as this tower, the towers basically are placed on 3 sides and are broadcasting in kind of 2 directions, and that ends up giving it that hexagon shape. Yeah, here's 3 corners here, and providing coverage over 3 equidistant lobes. I think I said 2 previously. I'm sorry, 3 directions. As the client moves from one area to the next, it's called a handoff. That used to be very choppy. Nowadays, it happens seamlessly, and you don't even realize it. Cell size can vary anywhere from 1,000 feet to a handful of miles, and it really depends on concentration in the area, number of users, and any other obstacles in the area. So high population in town, those cells are going to be small. Rural area where things are spread out, maybe hilltops, you can get towers up on the hills. You could have cells, span a handful of miles, if you will. Here's some cell antennas on the side of a building. Antennas hiding in a tree. I'm using little air quotes there. I have actually seen some of these as I'm driving around to try to make them look less of an eyesore for people. East Base Station has your mobile switching center, also called the MTSO, Mobile Telecommunications Switching Office. And this is the interconnection between the wireless and the wired, if you will. That's what's going on at those sites. As we go through the technologies, 1G, this was in the 70s and 80s, pretty much only phone, this kind of big phone that we have, cellular phone there. 2G was in the 90s. We started to do digital, and this actually paved the way for text and media downloads. And now we're talking basically 240K. 3G, early 2000s, data rates up to 384K. So now we're getting fully digital transmissions with GSM or CDMA. And now the data is using packet switching. And now we start getting into the early cell phone days, if you will, or early smartphone days. GSM, Global System for Mobile Communication. This is kind of the worldwide accepted standard. This one used TDMA, Time Division Multiple Access, so time slots for the users. Several of these smartphones then are in an area multiplexed together using those time slots. GSM initially only provided voice. Data was added later with GPRS and eGPRS to add in the data capability. GSM used your SIM cards. A lot of you might remember actually putting SIM cards in your phone as you might have moved from network to network kind of thing. CDMA, less popular, but CDMA, instead of using the SIM cards, compared your phone against a white list. Meaning, was your phone on the list? It was, okay, you're allowed to use our network equipment. So here, with CDMA, the signal spread over the whole bandwidth, a wider part of the bandwidth, and these packets were separated by codes. Codes on the packet kept the various calls separated, so it knew this code was this call, this code was this call. As we move into 4G, released in 2008, this was all IP network for voice and data now. So now we're in the 100 meg category with goal supporting gig speeds. With 4G, we now start having LTE and LTA. With LTE, this was kind of a marketing thing. This was like 3G, faster than 3G, but not 4G. So LTE was kind of like a stepping stone too. With LTA Advanced, this was actually for truly 4G. 5G, this was released in 2016, standards were, and started getting deployed in 2019. For a lot of us, if you've updated your phone recently, it's probably for 5G connection. So now we're up to 20 gig down and 10 gig up for our connection.